Hi again. Go ahead and turn to page 125 and follow along as we tackle this your turn problem, okay? It says the table shows the distance Allison drove on one day of her vacation. Is the relationship between the distance and the time a proportional relationship? Did she drive at a constant speed? Explain. Okay, so if I make a ratio of this, remember this is my x and this is my y, but remember I said that we are putting the y over the x in these situations. So if I have 65 miles per hour, 1 hour, I want to see if everything else is related to it, okay? So 120 miles per 2 hours. The stylus is kind of weird, so sorry about that. If I simplify this, then I'm going to divide by 2, and I end up with 60 miles for 1 hour, which already does not match this one. So I don't even have to go any further at all. I already know that it is not a proportional relationship because it is not the same speed. She's not going at a constant speed the whole time. The first hour she went 65 miles, and the second hour she only went 60 miles. So she might have stopped for gas in the meantime, might have slowed down her speed, but it is not proportional, not constant, and so no, it is not. Okay? Simple as that. Now, let's go ahead and erase this, and we'll scoot up our screen a little bit to tackle the next part of the problem, okay? All right. It says, write an equation for a proportional relationship. This is going to be a big part of your test coming up after Thanksgiving break. So let's give your best attention to this, okay? If there is a proportional relationship between x and y, so it couldn't work for the problem we just did, but it can work for the other ones, okay? So cannot work for something that's not proportional right now. If there is a proportional relationship between x and y, you can describe that relationship using the equation y equals kx. And the variable x is independent variable. That's why I mentioned it in the last video. And the y is the dependent variable. The k is called the constant. It's kind of like, what is that constant that you had to do, okay? And it represents the constant rate of change or constant ratio between x and y. The value of k is represented by the equation k equals y over x. That's why we've been putting that y in the numerator, okay? Because whatever we get with y over x is going to be our k. All right, so let's try this out. It'll make sense in just a little bit. But y is your y value, x is your x value, and this is the constant with the relationship with each other. Let's go ahead and give an example of it so it makes more sense, okay? Here we are. 2 pounds of cashews. Let me erase that for you. 2 pounds of cashews shown cost $19, and 8 pounds cost $76. Show that the relationship between the number of pounds of cashews and the cost is a proportional relationship. Then write an equation for the relationship. Describe the proportional relationship in words. Okay, so we made a table. We had 2 pounds equals $19, and if you multiplied that out, then you would end up with 8 equals $76, okay? And so if we did the cost of 19 pounds equals $2, if we got it down to a unit rate, if we simplified this, our constant would be $9.50 for 1 pound. It's kind of like a relationship where we said, remember this is the x and the y, keep that in mind. Okay, so we put the y up top, so your notes here, put y in the numerator, okay? Write that down somewhere. Take some good notes, okay? And the x is in the denominator, okay? And that's going to be like this for the whole entire unit, so make sure that you keep that straight. And I want to find out, what did I do to the x to get to the y? In order to take that 2 and get to 19, I multiplied it by $9.50. Essentially, 19 divided by 2, if I simplified that, equals $9.50. $9.50. That is like simplified, right? It's our unit rate essentially. It's our constant. If I did 3 times $9.50, I'd end up with $28.50. If I did 8 times $9.50, I end up with $76. So it's essentially saying if I put my y over my x, like I did here, this was my y, this was my x, and I simplified it, that would be my constant. Everything is the same. I know it's a constant because these two are the same number when I simplify them, just like here, right? So we know it's a constant, so check on the constant part. So now, since it is a constant, I can write this as an equation, okay? So all the rates are equal to $9.50 per pound. They are constant, so it's proportional. So I can write a relationship. So X is the number of pounds of cashews. How do I know that? Because I told you, you can always tell that top number in the chart is going to be our X. Okay? Let Y represent the cost in dollars, because I told you the bottom number down here is going to be our cost. Whenever we have a chart, you're going to have X and then the Y in the chart, but we're going to flip those around when we get to here. We're going to put the Y over the X. Okay? Got it? You'll need that later. But we're going to say Y, okay, use the decimal form of the constant change of rate. So we figured that out by doing Y over X, simplifying it. We got, what did we do to Y to get the X? Our constant rate of change was $9.50, okay? And so our formula, they said, was Y equals KX. And that K was the constant. And so we just fill that in. So we just leave it as Y equals 9.5 or $9.50. They just didn't use any units, X. Essentially, what's that saying is, in order to find out what Y is, I take my X over here, I take my X, and I multiply it times 9.5, and I'll get my Y. I take my X, I multiply it times 9.5, and I'll get my Y. If my X up here is 10, and I multiply it times 9.5, my constant, I'll end up with my Y, which will be 95. Okay, that's all it's saying. That's literally what this equation means. Y equals the constant times the X, and your constant is your change in here. Okay, we multiplied the X by 9.5 to get the Y. I know I'm over-explaining this right now, but you've got to get this down in order to for the rest of the unit and everything moving forward to make sense. So if you don't understand it right now, rewatch this video, talk to a friend, make sure that you get it, okay?